Imagine this. Thousands of people crowd around a brand new, gigantic ship. Flags are flying, bands are playing, cameras are ready. Years of engineering, millions of dollars, and the reputation of an entire nation. All balancing on a few terrifying seconds. The signal is given. The ship starts to move. And then, instead of gliding proudly into the water, it lurches, tilts, and catastrophically fails right in front of everyone. How does something designed by the smartest people in the room fail at the very first moment of its life? Today, we're diving into some of the most disastrous ship launches in history, and the surprising human mistakes that caused them. Stay to the end, because these failures still teach us a brutal truth about modern engineering, AI, and even our own decision-making. Before we talk about failure, we need to understand the launch itself. Launching a ship isn't just push it into the water. For huge steel giants, especially in the 1800s and early 1900s, the process was more like a carefully choreographed fall. Most big ships were launched sideways. They rested on a wooden or steel cradle that sat on greased rails called slideways. At the right moment, workers released the restraints, gravity took over, and the entire ship, thousands of tons of steel, was expected to slide smoothly into the water, without breaking itself apart, flipping over, or dragging the launch system with it. Think about that for a second. You're asking one of the heaviest man-made objects on Earth to perform a perfectly controlled slide into an unstable fluid. There is almost no room for error. And yet, error happened, spectacularly. Let's start with one of the most famous problem launches, the SS Great Eastern. In 1857, this ship was a monster, the largest in the world at the time. Designed by the legendary engineer Isambard Kingdom Brunel, it was supposed to be a symbol of British technological dominance. But there was a problem. During launch, the mechanical system that was supposed to help move the ship along the slideways just couldn't handle it. Winches strained. Chains groaned. The ship barely moved. What should have been a single glorious moment turned into a long, embarrassing struggle, spread over multiple attempts. Newspapers mocked it. Investors panicked. Brunel's reputation took a hit. Technically, what failed was the launch mechanism. It simply wasn't powerful or reliable enough. But beneath that was a very human issue. Ambition was sky high, but the launch system was not realistically tested for something this massive. In other words, people underestimated the difficulty of moving a ship this big. Sound familiar in today's world of giant rockets and mega projects? Now, mechanical failure is bad, but what if the ship launches and then immediately sinks? That's what happened in 1883 with the SS Daphne in Glasgow. The Daphne actually entered the water. So, at first glance, the launch worked. But within seconds, the ship rolled, capsized, and went under, taking many workers' lives with it. Investigations pointed to multiple factors. The ship's ballast wasn't properly managed. The way it was loaded and controlled during launch made it unstable. And critically, the systems meant to keep it safe were either misused or not fully understood. This wasn't a single broken part. This was a failure of control, of planning how the ship would behave the moment it floated free. Again, the core problem was human. Pressure to launch, confidence in it will probably be fine, and a lack of rigorous testing of worst-case scenarios. Then there's the Principessa Yolanda in 1907, a textbook case of what happens when the math looks good. But reality doesn't care. On paper, the ship's design seemed acceptable. But during launch, as soon as it hit the water, it started to roll. And just kept going. It capsized right there in front of everyone. The main issue? Its center of gravity was too high. Think of balancing a broom vertically on your palm. The higher the weight is, the harder it is to keep stable. Ships work the same way. If a ship's center of gravity is too high, even a small tilt can turn into a full roll. During the launch, small disturbances and water motion were enough to push it past the point of no return. Here's the scary part. This wasn't just a random accident. It suggests that either the calculations were wrong or that real-world conditions during launch were never properly accounted for. Once again, it traces back to human decisions. If you look closely at all these disasters, SS Great Eastern, SS Daphne, Principessa Jolanda, you'll notice a pattern. Yes, there were mechanical failures. Yes, there were design and control issues. Yes, physics played a role. But behind all of that were people. People under pressure to meet deadlines. People afraid to delay a high-profile launch. People confident that we've done enough testing. Ambition, pride, time pressure, and sometimes overconfidence quietly set the stage long before the ship touched the water. And that's what makes these stories so powerful. They're not just about old ships. They're about us. Today we build AI systems, humanoid robots, self-driving cars, and mega projects that are far more complex than those early ships. But the core risk hasn't changed. The technology fails when the humans behind it rush, assume, or ignore uncomfortable data. So the next time you see a rocket launch, a new AI model, or a futuristic robot, remember, the most dangerous failure point may still be us. If you enjoyed this deep dive into the hidden side of engineering disasters, hit like, subscribe to Bio-Inspired Tech, and tell me in the comments, which failure should we analyze next? Rockets, bridges, or AI systems gone wrong? Thanks for watching, and I'll see you in the next one.